Okay, in this video we are going to look at parametric equations when we are dealing with the unit circle and when we're dealing with angles. So sketching the graph, we're going to sketch the graph and we're going to indicate the orientation. So we're going to show with our arrows which direction or how the direction is changing on the coordinate plane as t passes of its time. In this case, it's an angle. So as the angle changes, we're going to show direction on our graph. So we're going to verify the graph using our calculator. Well, we're not going to do that part. I don't know why I keep saying that. And then we're going to find our rectangular equation for the graph. All right, so if you'll notice, I've got my unit circle right down here just to use as reference for this problem. So I've embedded it in the problem or in the paper here. So if we look at this, I want you to firstly recognize that we're going to have to create a table of values again, just like we did on the other problem, so that we can get an accurate graph. So t, notice now, is changing from 0 to 2 pi. So if we look at the unit circle, that means we're going from 0 right here to 2 pi. So that just means a rotation around the whole circle. That's what that indicates, okay? So I'm starting at 0, I'm moving this way to 2 pi. So we are just going to basically choose the easy points on the graph to do this, and the easy points are going to be at the quadrant values. Okay, so what I'm going to do is write t0, t at pi over 2, t at pi, t at 3 pi over 2, and at 2 pi. Okay, so those are our total restrictions for t. Okay, so now what I'm going to do is I'm going to look at the fact that my equation for x has cosine. Well, remember the x value in our ordered pair is cosine and the y value is sine. So we're going to use this idea to fill in our table. So x is equal to 2 cosine of 0. So at 0, the cosine value right here is 1. So what I'm essentially doing here is just replacing cosine t with its value at that ordered pair. So it's 2 times 1, which is 2. This is easy. Okay, so now at pi over 2, I'm going to do the same thing. At pi over 2, cosine is 0. So 2 times 0 now would give me 0. And then at pi, cosine is -1, so 2 times -1 is -2. And then at 3 pi over 2, cosine is 0, so that would be 0 again. 2 times 0 is 0. And then at 2 pi, cosine is 1. 1 times 2 is 2. So that's how we get our x values. We're going to go around the unit circle again now and find our sine values. So y is equal to 3 times the sine of t. So at 0, again, that's right here, our sine value is 0, so 3 times 0 is 0. At pi over 2, the y value is 1, so this would be 3 times 1, which is 3. And then at pi, it's 0 again for the y value, so 3 times 0 is 0. And then when we get down here to 3 pi over 2, it's -1. 3 times -1 is -3. And then at 2 pi, it's 0 again, so 3 times 0 is 0. So now I'm going to write out my ordered pairs here. So I'm going to start here. That's my initial point. So at 2, 0, and then at 0, 3, and then at -2, 0, and then at 0, 3. And then at 2, 0, it just repeats again. So my initial point is at 2, 0. And if you'll notice, this is an ellipse. Did not do a great job drawing that, but that's okay. And then, of course, our next value is 0, 3. That indicates that we are moving in the counterclockwise direction. All right, so finding our rectangular equation, a little trickier for these than it was on the others, because we have to consider the fact that we can't solve for t here. We can't isolate t. We can isolate cosine t and sine t, so let's do that. So x over 2 would equal cosine t, and y over 3 would equal sine t. Well, notice that since we have an ellipse, that means we have an equation in which our x value and y value are both squared, added together, and equal to 1. If you'll notice, this does not look that way yet. So we have to use what we know about the relationship of cosine and sine. If you'll recall from our identities chapter, I know that cosine squared t plus sine squared t equals 1. That is the form that I need for an ellipse. So I am going to replace cosine t with x over 2. I'm going to square it. I'm going to do the same thing for sine. And what that gives me is y squared over 4, or sorry, x squared over 4 plus y squared over 9 equals 1. And this value is 2, so the square root of 4. This value right here was 3, square root of 9. Life is good. Easy peasy, lemon squeezy.